All right, let's look at the homework 1.6, 1.7, problem number 3. All right, so we have this reducible second order differential equation. Let's solve that. All right, so we're gonna let all right, so we're gonna let the y prime is equal to p, and which means that if y double prime would be simply p prime, right? So the differential equation becomes now we have x p prime is equal to p, right? Then you can do this as a separable equation, or you can do it as a first order linear equation. I'm going to do it as a first order linear equation. So I'm going to subtract p from both sides. Then you have x p prime minus p is equal to 0, right? Then I'm going to divide through by x, so that we have a p prime minus 1 over x p is equal to 0, right? Then integrating factor I is going to be e to the integral negative 1 over x dx. So this is going to be e to the negative natural log of x. Then we can place this negative sign up here. Then we can cancel e and the natural log. So we just going to get e to x to the negative 1, right? So therefore, p is going to be 1 over integrating factor. So reciprocal 1 x to the negative 1 would be just x. Then integral of 0 times I, which is going to be 0 anyway. So you have x to the negative 1 dx, right? So this is going to be just 0. So we have an antiderivative of 0 is a constant. So you're going to have x times c. So I'm going to write it as a cx, right? But remember that the p is originally y prime. So we know that the y prime is cx. So in order to get the original function back, we can just simply take the antiderivative. So you're going to have cx squared over 2 plus some constant, say b or something like that, right? Then you can see that there's no point of writing c over 2 because just a number. So we're going to call that a. So therefore, we have y is equal to ax squared plus b, right? So that's what we have here. All right, that's it. I hope that this was clear.